In this example, we're going to look at a product of exponential x and the log of x. So we go through our process again. We're going to use the formula for the integration by parts, which is up here. So we have to identify u, dv, v, and du. We have to evaluate v and du. So the first question is, which of these two will be set to u? Is it exponential x or is it the log of x? So we come up to a rule, and the first one on the page is, if one of the factors is a log function, this must be taken as u. So u is equal to the log of x, and that means dv must be the rest of it. So dv is exponential x dx. I differentiate du dx here. Du dx is 1 over x, and that implies that du, which we need for our formula, is equal to dx divided by x. Over here we have du now, we need v, so we integrate the integral of dv is, if I go back here, I want this in red, so v, and the integral of exponential x is exponential x. So we have every term we need to put into the formula. So the formula is the integral of u dv is equal to u, which is the log of x, times v, which is exponential x, minus the integral of v, which is exponential x, times du, which is dx over x. And this gives us exponential x, if I just bring that to the front, times the log of x, minus the integral of exponential x divided by x times dx. Now the only problem here is there is no direct integral. This cannot be integrated directly. So what we're going to have to use are the Maclaurin series. We're going to have to approximate it using the Maclaurin series for exponential x. So exponential x by the Maclaurin series is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial, and so on. And it goes up to x to the n over n factorial. Now, if you go and divide every term of that by x, you get 1 over x plus x divided by x plus x here, x squared becomes x, and 2 factorial is 2. X cubed divided by x gives me x squared, and 3 factorial is 3 times 2. X to the power 4 divided by x is x cubed, and 4 factorial is 24, and so on like so. Okay. So now we have that, so what we do is we integrate that. So the integral of, that's x, integral of exponential x divided by x dx is the integral of 1 over x dx. We can do each of these individually. The integral of x over x is 1 dx plus the integral of x over 2 dx plus the integral of x squared over 6 dx plus x cubed over 24 dx. And if we integrate each of these, the integral of 1 over x is the log of x. The integral of dx is x. The integral of x is x squared over 2, but we already have a 2 there, so it's x squared over 4. The integral of x, this is 1/6 times x cubed over 3. This is x to the 4, and we have 24 times 4, and so on. So if you evaluate that, we have the log of x plus x squared over 4 plus x cubed over 18 plus x to the 4 over 96. And I'm only including the first 4 terms, but you could go on ad infinitum there. So the approximation, because we can leave all the smaller terms out. So if we leave those out, we can just approximate this and say that the integral of exponential x times log of x dx is equal to, and we go back up here and we take this bit down here, exponential x times the log of x minus, and this term in here, we can replace that with everything that we see down here. So that's equal to minus times the log of x plus x squared over 4 plus x cubed over 18 plus x to the 4 over 96 plus, and we can go on. But that should be enough terms to approximate it with enough accuracy. Okay.